these things. Now we have to open the same file what we had yesterday, what we had imported the file to the checkboard. To we have to open the same file. How to open that file? So if you open Idea Statica, this one we have here checkboard option. If you click on this checkboard option, we can see all the previous created checkboard folders. In that we can click on one folder and we can get the same yesterday's opened file. See, these are all the files which we had created in the past. So if I click on this file, open, it will open the file from the same location. So this is one way, and another way is we can open the file. If we are working the same file, we can open the file. I can close this again. I can open from, otherwise I will just show you. I can open this from again from tools like Idea Statica. It will open same thing, same file. These are the two ways to open this checkboard again, same checkboard. So after opening the checkboard, we have to select the connection what we had done yesterday. Or otherwise, if you want to do new connection, we can open the connection. We can import the connection, the new one. So these two are open, but only one will work. So we have to close one. So after opening this one, if you want to do the same connection, we can work on it. Otherwise, if you want to do on the same another new connection, means we can import some other new connection, like somewhere here. We can yesterday we had imported this one. Okay, I will import this one. Just select that one and go to checkboard and put import connection and click on connection, then it will come. Yeah, checkboard is open now. Now after opening this, you can click connection. This next remaining whatever we had selected, this one will import now. So this is also imported. Now we are going to do the connection of this one. Like there's instead one more option is in here. After coming to Idea board, Statica board, there's an option here, merge, divide. So we can divide the beam. If we select one beam and we can select the divide option, then you can divide this beam, like on the same way you can merge this beam like this. If you select this beam, merge option is hide selecting it. You can select 14M1407 and select this one. You can merge this. Actually, before it is a two beams, now it is asking for merge anyway, so we can merge it. So you can see here this before we have an opening, now we have the opening was closed. It is the same single connection is there, but it is a continuous member now. We can see the forces with the before we had seen member end and member end, both ends like begin and end. Now we can see begin and end of these forces. Like again, I will open the connection. Can open here. Same yesterday. Before yesterday we had seen split, but after importing from to here, we can't do anything to this beams. Like we can't divide and we can't merge here. But before there we can do here. We can do here this one. We can divide this again. We can merge this one. Similarly, we have like loads. For loads, we already discussed. We can have uh, different set of cases which we want only to import, and we can work on only on that design. So next, another option like connection, we can have a connection. This option is like we can create a connection. Let's we have a connection node. You can select the connection, that location, and the connection will create here. Then press enter, it will create a connection. The connection was created here. So this connection we can import. If you can open now, you can see the forces of that beam only. See, we got only one beam. So we are opening that beam connection now. So like this, we can do in checkboard this many operations we can do it. So we can, and also there may be some settings like we have some pre-designed settings like bolt assemblies, what you have to take, what is edge distance. This week already predefined. It's already based on the code. It will be defined. If you want to change anything, we can change these things. And load extremes. This also this limits also like what is a normal force and shear force, how much minimum this much required actually to design. Next, after going to the connection, then checkboard is almost things explained. But only thing is this is we are going to do only connection design here. We are not doing the member design. There is an option like member design also. We can do the member design. Like if you do the member design, there is a see I already created one member. This is the member. For this we can create member like if you select on the member, if you select this one, then enter, it will create one member here. Then we can design that member also. We can design that member for that one. If you we have to open that also, and it will be opening like differently. It's not like a connection. So this here again remaining options are current item. So this if you have any update in the start model, you can sync it. So this is the thing. Member how we can into design. This is the forces coming on this member. This is the member attaching. So this all ULS. This is completely different. So we will not use this actually because we are using the for member design. Member design for Stat Pro. We have analysis software. So we are using that one. We are not using these things. So here same thing again design check. So we will get to know that one means we can do something here. So right now I'm limiting this one to here itself. So I'm closing this one. So after opening the connection, I have taken one typical connection here. This is a one column member connecting with the hunch. This is also predefined connection actually. So with hunch we got it. This is connecting directly to the web itself. So here we will see now what is how we are going to design. Before designing, what is the requirement is materials. So first we have to go to the materials. Actually we normally materials will be there. If we not that maybe code based on the code we have some more requirement like S355 material is there. So if you have any other AS-A36 material like that, if you want means you can add that materials here. If you go to steel, you can have many things. See for EN code, this many materials are available. If you want to add these things, you can add here. Then this one will be reflected in while selection the material of the member. If you go here, if you want to select here this material, uh, here it will ask you the material type. So here if you select the material, it is giving only S355 because directory it is telling only S355 is available. So if you have here, then it will come there. So if you add here something, then it will come automatically. S275 added. So it will come there. Again, if you want to add by like my project deals with the stainless steel, which is not available in this grade. So how can I do that? analysis. So we can have our own material edit. We can have a we can do some like add any one material type and edit it. You can edit that. So this one will be edit of S275. You can give that here stainless steel. You can give properties of those things. Then you can save it. So automatically the name and all these things will be changed and it will be assigned to this one. So after this is done, so after you go there and you can take similarly the bolt assembly. Bolt assembly, whatever we have taken right now 8.8 grade only. If you want only remaining grades, we have to import it here. So then only that one will reflect there. Next, bolt grade, same bolt grade, whatever we have, what is the bolt grade? That also we can edit. So if you add one bolt grade and we can edit that bolt grade. Edit means if you edit this one, then it will edit. And if you can save, you can save it. That's all. Then it will be saved. You can copy this and you can make it another one. So then after saving, while saving, it is asked to which table you want to assign. This ECUO code, it is we are assigning that one. Then going to design again. If for the design, then it will ask you what are the materials we have. You can see we have stainless steel S275. What we had given there. Then only it will come here. So we have to first assign the materials. So if you have different materials other than the provided here, so go here, go there and do the remaining work. Then now properties also we can have the directory, complete directory of remaining, like we have any type of member. See here the cross section can be anything. How to select that cross section? See here, if you select plus button, this add new button, you can have this many type of rolled section. These are welded section, these are cold formed, and these are timber sections. So in welded you can have double sections and these things. You can edit these things. In rolled, like this is already defined categories like AIC, steel, American, European, like this. So if you in this also there is if you select here, see you can give the height, width, everything, and we can assign that member. You can give some name like SS something. You can give that name and you can save it. Then it will give you that here 1, 2, 3 will come. So we are using right now two profiles only will be there. Whenever we are adding another one, the third one will create with that profile name. So if you want to use the old one also, you can select it. Otherwise, if you want to use only other new one means you can select this one. No, if you want to edit this one again, already you created one section here, SS1766 or something. We want to edit the thickness of the flange again. So if you want to click, no need to click on the plus button. No, you already created the section. You want to edit the section. So edit the parameters now. Again, the parameters will open here. Then you can edit anything you want to edit. If you want to edit something means you can edit that. Then can go here and you can press OK. Then it will come. That's all. Thus, only edit will help you to change the properties of the section at any time. So that will be changed, saved only in the third member. Otherwise, if you want to add it to another profile, you have to go for add new. Then only it will come to new section. Then that is finished. Next, here the rotation of the sections here defined by rotations. There is a two options to define the position of the member. If you select the three rotations, you have to give in three directions: alpha angle, beta angle, p. How it will rotate, I'll just show you. Just if you give 45 degrees here, I will rotate. This section was rotated by 45 degrees to the, and in this angle of radially it was rotated. The same thing you here, it went up, so it is rotating in y direction. This all thing you have to, while doing another connection, you have to do see like test like trial and error method, like you have to do that, because you don't know the exact position. We can't remember this values. How this is fixed, we can't remember. These are not remembering values. Just you have to do trial and error method only. This idea static is full of trial and error methods. If you want to see in the drawing, it will, you can see the drawing, how what is the measurement, what we had taken the measurement. If it is enough, okay. Otherwise, we see right now the bolts are clashing, so we have to see and we have to adjust the things. That's all. So this is just completely trial and error method. Again, I am giving here the another value, another. So this is rotating against the z value. So these are the things. This will be rotated by the way. And next, if you go for 3D vector, here there is a 1 0 0. This you can't understand actually. This based on 3D vector only it will rotate. So we can't understand that is that easily this one, because if you give 0 and again if you give 1 here, you have to give space 1 0 1. That's all only. See, it is rotated in that axis like that. So axis, this x and y and z axis, all rotation is the rotation. So you can rotate in that axis like this. So you can, in that rotation, the axis will be rotated in x-axis. And this is a way. And after doing this, we have offset. What is this offset? Offset is like we are having the member already in one position, but some positions will be having eccentricity with the column. Like see, we can have 30, 50 mm eccentric. So it is already connected to the member. So it is not showing me in x direction. It is not showing me any offset. So if I give in y, see in z, y if I give the y, it is moving in this way. In z, if I give, it will go up. So z is up for the ideostatica actually. So in z it will is going up, and next it will, in next also if you want to move it, means you have to remove this weldings. After removing the welding only it will go. Some more completely welded. So this is welded with stiffness. So like right now I can't remove it. We can have another member, new member, then we can move the members accordingly. You can see that. Okay. Next. Put some same again, Jojo, and align with the node. This one can like this one when we have a node at the center of the column, right? So this one will be aligned with the node, or otherwise in the position like that. It with the member plate. There are two options for this: align with plate or with related to plate like this. Or if you select node, it will select only with the center of the node what we had imported from the STAD. So forces which we are importing, the forces are in the node point or from the position point or in the bolts point. So that point we can give that. For nodes right now we are taking from the node point only. So we are giving only for node point. And this one model type, when we are going to design the moment connection, then we have n, vy, vz, mx, my, mz. Then we are going to for design only for shear connection, we can select only n, vy, vz. Then it will ask you the loads only 3. We can give only 3 actually. It will update automatically. We don't need to give only, we can give only 3. But we had updated in here, we have to update here also. Then it will change. See, this is not editable right now. So loads are not editable only because we are going to connect for shear connection. And another parameter here is bearing member. So we have to set which is a bearing member. Means we are going to design the connection for the beam. So column will be a bearing member here. So we can set this as a bearing member. Again, if you want to do another, if there is another member which is going to be a bearing, then we can change that. If you select here, you can have an option here, set bearing. So we can set this as a bearing. If you select this as a bearing, then we have to give the forces to the column. So you can see here, see now we are in loads in equilibrium. If you click it out, now the bearing member is beam. So we have to give the forces to the column only, the begin and end. If you select the column as a bearing member, then we have to give the forces to the beam. So this is only validatable. Only beam forces we have to give. That's all. This is the main part of the for the column member section. After the next code setup also there. In this already code setup will become from the code itself. It will be there or will predefined. It is already predefined. So everything will become everything. So if you have any doubt, you can change it. Like and you can see the like dimension check also it will be done, like how much dimension, like 2 into 2.5 times of the volt to voltage edge inside distance to be maintained, edge distance to be maintained, that and all you can give the parameters. So that check also can be done and will be give the error like it is not maintaining, like that you can give. Under the members length, normally the length of the member will be here 1.25 times of the, it is like we can give that member length here, default length for the standard member. Right now we for the normal sections it is 1.25 time, and also hollow section also 1.25. This also we can edit it, because when we have more moment and more shear values, this moment will be having more, because the member will be passed in stat but it will not pass here. Because of that, the member length it has taken more. So if you make it less, it will pass it will pass. So that these things we can modify it. And also division of surface for the hollow, like these are all we can see what are the parameters on which how maximum this only will be helpful for you, this too, because the length of the member is the maximum thing required. Next, now here number of buckling modes to check, and everything will be available here. Then remaining checks, whatever check settings here available is there, you can check whatever the things required, what are the limits values, you can assign that values. And when we have a concrete, it will check for the cracked concrete also. If you take this one, if you didn't take it, it will not check for the crack of that concrete. And also this the concrete block parameters we have to assign for that one. These are the safety factors for the remaining things. So now the members were done. Next, the load cases. Load cases we have already I already told yesterday itself how to import it from the already existing stat connection, that is connection import. If we have the connection as a similar type, we can import it directly from the IDEA Statica model itself. From the connections you can import, there will be connections here, but the thing is the configuration should match, then only we can import it. Otherwise we can import from the directly from Excel we can import it the position. And no Excel position, like if you are going to copy only the forces, means you have to select this one, you have to select this one and paste it. And import only extremes means if you want only extremes, you can select this one and it will import only extremes. And another option is replace existing loads. If you have another already 1 2 loads, it will be replaced by that load. Otherwise it will create new loads. That is the option. And another options, like if you right click here, you can have select all option or unselect all option, and clear and load, calculate load extremes options. These are the remaining options. We can have the new load also, whatever the loads we can want to give, we can give. So right now I'm designing the beam, so I can will give like tension 50 kilonewton and compression same 50 kilonewton I will give. So if without any load, it will not. If any case should not be there any load. Definitely one single 1 kilometer load also should be there, because without any load, in any case, if any load is not there, means stat will give you warning. IDEA Statica will give you warning, like it will not run with empty cases. We have to untick that one, otherwise we have to delete that one. Otherwise we have to give some load to that, then only it will run. Right. After coming here, this is the operations. Like operations is means creating the connection. How to create a connection? There are many operations available to create a connection. These are all the operations after taking the from the predefined one. If we have some adjustments to that one, we can take anything, these things, and we will explain one by one, and we can take into the next sessions how it will be done by the connections. Okay. Now I'm just running the connection. See, bolts are too close to each other. That is a manufacturing operation. That's why it is giving the error. So bolts are very close. So we have to adjust that. Here this is the end plate already I had taken. This is the end plate operation. End plate operation. What are the specific requirement here is end plate can be attached to the member and member B and to the connected to the column. You can have this member to the another member also, but we are not having another member, so we are just giving only one member. And material grade we have to select, and the type of thickness of the plate we have to select. Like the thickness of the thick plate can be anything 10 to 20. You already know the thickness of the plates, so you can select anything. And connection type, you are going to bolted or welded. If I go to welded, it automatically bolts will be deleted. So one operation I can run the analysis now because there is no bolts. That's it's must. But here also there is one side stiffness are there, one side not there. So if you go here, there is rear option. We can have both. So the both stiffness came now, and the same way stiffness. We will explain this in the next further sessions also. How to open this first, how to add this operation, then how to create it and how to modify it and how to do these things. So okay, right now a session was ended. You can have any doubts, or otherwise you can have any queries. Anyone has having any query and can ask it. No one has any doubt. Okay, thank you. Did you understand? Just if you understand, no problem. But if you didn't understand, only problem. Right? Okay.
Yeah, okay, sir. Bye, sir. Thank you.
Thank you, sir.